Hi, I thought the best way to answer your question was with a little video. I'll do a basic explanation of an exponential function and what we're talking about with that. And then I'm going to talk more specifically about your question that you included in the email about the bats. And we'll talk about those. So generally speaking, exponential function, it's expressing something that's happening over and over and over and over and over again. The example I like to give is if I was holding a basketball at my head and I dropped it and it bounced halfway. And then the next time it bounced halfway again and halfway again and halfway again. In theory, it would continue to bounce forever. Now, we know gravity takes over eventually, and physics is a little different than theoretical math. But in theory, half, forever and ever and ever. And how that looks as an equation is we're looking at saying that we're going to take our starting point, which I'll talk about in a second. We're going to take half of that. And then we're going to take half of that again. And half of that again, and half of that again. And we could keep going. And so exponentially, if we're multiplying something over and over and over again, half of this, half of that, we're looking at doing 1/2 over and over and over again. In this case, 1, 2, 3, 4, 5 times. So we have 1/2 to the 5th power. And the way we would say that is that our common ratio, the rate at which it's changing, is 1/2. And the 5th power tells us how many times this has happened, how many bounces in this case. Now, I mentioned that we'd have to have a starting point. You don't start at 0 and go half of there and half of there. That doesn't contextually make any sense. But I'm 6 feet tall, and if I hold the ball at 6 feet high, so now I'm starting at 6. So that's my starting point, and I take half of that, that'd be 3. Half of that, 1.5, half of that, 0.75, half of that, point something, half of that, and so on. And so this example would look something like this, where you would have some starting point times our common ratio, or the rate at which it's changing, to some power. And that power tells us how often this has happened. Generally, we would write the equation as some starting value A. I believe Newton uses B to represent the rate at which it's changing. I'm going to use R simply because R works better with the way we talk about rates and ratios. But B is in the Newton, to the power of something. And so this is your general exponential function right here. A times R to the n power. Specifically for the bats, it tells us that after 2 hours, there were 180 bats. We don't know how many bats there were to start with. We don't know how fast they're having more bats, how fast the bats are changing. But we do know that after 2 hours, there were 180. So I can fill in my formula with some information. We also know that after 5 hours, there are 1,440 bats. It's a lot of bats. And again, we still don't know how many we started with. We still don't know how fast that's changing, but we know it was 5 hours later. How we can use this information to help us is that we have 2 equations and 2 unknowns. A and R are unknowns. We have 2 equations that relate A and R together. We can solve that. That's a system of equations. It's not linear, but it is a system of equations. So I'm going to solve for A. And if I do that, I'm going to get something like this, where I have got 180 over R squared equals A. And similarly, I can do the same thing here. And I can solve for A. There we go, R to the 5th. And then I can use substitution, and I can put those 2 equations together. More or less, I can squeeze them together using the transitive property and say, don't worry about that term if you're unfamiliar. This is easier to write on paper, but there we go. Okay, so I've squeezed those two equations together. I've used substitution to put them together. Now I have one equation with one unknown. I'm going to cross multiply and I'm going to divide. I'm going to let you try this on your own. So I'm just going to jump straight to the end of the cross multiplying and dividing. You're going to end up with this equation here, r to the 5th over r squared. There you go. And the first half of that, the left side, 1440 divided by 180, that's basic arithmetic. Use a calculator if you want. That's 8. R to the 5th divided by r squared. We can use rules of exponents now. So if you remember r to the 5th divided by r squared, if you're dividing exponential powers, you can subtract the exponents and you get r cubed. And there's a lot of reasons behind that. It's not just magic, but I'm not going to go into that now. You now have a choice. You could just know that 2 times 2 times 2 is 8. This is a smaller cubic, and so it might be one that you recognize. If not, you can always take the cubed root. You can use a calculator. You can use online calculator if you need to, but take the cubed root of 8, and you're going to get that 2 equals r. The question did not ask what is r, what's the rate at which this is changing. It asked after 9 hours, how many bats were there? We know the rate. We know how fast the bats are increasing, how fast the number of bats are increasing. But if we want to use our function here, our general exponential function, we still don't know the original amount. Luckily, we have 2 different equations here that will tell us the original amount. So if we know that r is 2, because we've solved for r already, r is 2, we can plug that in. We can substitute 2 for r. 2 squared is 4, and 180 divided by 4 is going to equal 45. So by using this equation and substituting our value for the rate r, we get that 180 divided by 4 is 45. Now I know the rate. I know the initial amount. I know I want it after 9 years. I have everything I need. So I'm going to say that if we start with 45 bats, and we know that every hour the number of bats doubles times 2, and I want to know after 9 hours times 2 times 2 times 2 times 2 times 2 times 2 times 2, 9 times. Again, that's plug it into a calculator. I'm not going to do that in my head by any means. I'm going to get 23,040 bats. Yeah, that's a lot of bats. Gross. Great for eating bugs, but yuck. So that's how you can use or utilize that general function or general form of an exponential function and use some arithmetic to solve for what you need for those problems. Hopefully that helps for that particular question.